And these rules are very, very important. We cannot break any of them during the analysis. Okay, so let's look at rule number 1. So rule number 1, we specify, okay, that we have to apply that Vy and Izz, okay, are constant regardless of the size of the defined area. Okay, so what we mean by that, right? So I'm going to copy this diagram again. I'm going to paste here. Okay, what rule number 1 means, okay, if you want to find if you're going to find the shear stress of the entire, wait, let me use a different color. If you're going to find the shear stress of this shaded region that I told you that I'm writing down here, okay, so down here the shear stress is equal to Vy over Izz. Okay, I will call this QZ1 and T1. Okay, now if we are going to find another, or we're going to find now our defined area change. So let's say now our defined area is this entire area above the centroid, right? The shear stress will be equal to still Vy over Izz, QZ2 and T2. Okay, so regardless of the size of the defined area, and this is very important, the Vy, okay, the Vy and Izz are constant. The Vy and the Izz are constant. Are we clear? Okay, so that is rule number 1. Rule number 2, when deriving later on, when we derive the formula or the expression, rule number 2 that we have to oblige or we have to obey is the geometric datum okay, the geometric datum is always at the geometric centroid. So what this means is this is our geometric centroid, and this is our geometric centroid. Why I specify the word geometric centroid? Because the centroid is defined based on geometry. Okay, so our datum, the symbol that we draw for datum is this symbol. Okay, that is our datum. This is where at this line over here, y is always equal to what? 0. Okay, at that line, y is equal to 0. Okay, so we have to know these two rules. The first rule, regardless of the size of the defined area, Vy over Izz are constant. Second rule, the geometric datum is always at the geometric centroid. Those rules you have to apply. Okay. Now, the next thing we're going to do is we are going to look at the centroid. Okay. Oh, sorry, first moment of area. So I'm still going to copy this diagram. So now we know, Okay, so before we go on, let's look at this formula that I'm going to highlight. Okay, come on. This formula that I'm going to highlight. Okay, so we already know Vy is constant, Izz is constant. Next, we're going to find what is Qz, or how to find Qz. Okay, so let's look at Qz. So Qz Qz is equal to A y bar. Okay, and why we use Qz? Okay, why we use Qz is because our shear force is coming in the Vy direction. Okay, that's why we use Qz. Okay, so now by looking at this, Qz is known as the first moment of area, right, about the z-axis. So what this means is this axis that I'm highlight is the axis, the reference axis. Okay, so that is the fixed axis. It is the axis where the first, or where the area will be taken from, and the perpendicular distance is measured relative to the axis. Okay, so you can see from here, right, we are going to find AZ is equal to AY bar. Okay, so what I tend to do, because ZZ is the axis of interest, I will label this as my width, like before, and by perpendicular distance is my depth. Okay, so QZ is equal to width multiplied by depth multiplied by Y bar. Okay, so you can see that the width for this case is equal to B, right? So now the Y, sorry, the depth, now this is the area, the defined area that we are interested now. Okay, this area that I'm shading now. Okay, so in order to find the depth, okay, in order to find the depth, we know that this is equal to C minus Y, right? Because this distance from here to here is equal to C minus Y. Okay, it cannot be Y minus C. It has to be C minus Y. Okay, so once you see over here, we are going to create another rule. Okay, we're going to create another rule, but let's finish this equation first. Then you have Y bar. So this is the Y bar value over here, and Y bar value is C plus Y multiplied by half. Okay, C plus Y multiplied by 0.5. Okay, so this term over here is your area. This term over here, okay, this term over here is your Y bar. So now some of you might say, Eugene, right? Why is it C? Why is it Y bar C plus Y times by half? Okay, I mean, formulas are important. Sometimes you forget. Okay, there are ways to help you. Okay, so for example, if I put this as 4, right, the bottom line over here is 4, and if I put this at 6, right, and the Y bar is the defined area centroid, what is Y bar equal to? Can anyone make a guess? It's equal to what? Anyone? No?
Check is 5.
Yes, it's equal to 5, right? And that is done by observation. If you apply this formula over here, right? If you apply this formula over here, so C is equal to 6, Y is equal to 5 times by 0.5 is also equal to 5. Okay, so that's why y bar is equal to 5. Now, I want you all to focus on the area. So we know that the area is equal to B C minus Y. Okay. Now C, when it's relative, okay, when it's relative to the centroid, or to the datum, okay, so we know that Z over here is our datum. And at point C, right, what you see at points at the distance C, right? So C, when relative to the datum, correspond to Y max. Yes or no? It corresponds to Y max. Okay. So from here, the rule number 3, okay, rule number 3, okay, rule number 3 states, okay, based on C is the maximum distance from the centroid, we will define that the analysis, okay, the analysis starts from the distance furthest away from the centroid. Okay, so if I'm going to draw where the analysis direction starts and where how is it flowing, I'll draw this straight line over here. Okay, and I'll draw this arrow coming down. This is going to be the analysis direction. Okay, and what we realize in this case, right, when by looking at the figure over there, the area is equal to 0 when, hold on, the area is equal to 0, right, when y is equal to y max and y max is equal to c, right? And we realize when the area is equal to the maximum is when y is equal to what? 0. Okay, just I want you to observe in this. Okay, right. So now coming back to our equations, or our equation in first moment of area. Okay, we realize that QZ is equal to B C minus Y C plus Y multiplied by 0.5. So if we were to tidy up this equation, the first moment of area, the function for the first moment of area is 0.5 B C squared minus Y squared. Okay, so that is our equation for first moment of area. Okay, now the next thing is this. I'm going to write down rule number 4. Okay, so rule number 4 is that the first moment of area okay, for a solid structure cannot cross over is centroid.